Hello guys.
Morning, sir.
Good morning. Sorry guys, today I'm little late. I have some neck problem, constantly I'm working on the computer 8 to 10 hours a day. 4 or 5 hours with you guys. Yeah, and then after my research and all other stuff. So, but it's okay. Okay, let's start. All of you are here. Please say your name. Say your name.
Elias.
Next.
Paul.
Next.
Margie Vias.
I can't see you. Okay. Next. Next. Nina.
Nina Rodriguez.
Good. Next.
Solomon Harris.
Who?
Solomon Harris.
Solomon. Oh, okay. Solomon Harris. Okay. Next.
Nathan Light.
I can't see and I can't hear.
I'm right here.
Okay. Sorry. Next. Next.
Ishmael Taylor.
Ismail Taylor. You are here. Good. Next. That's it?
There's the line.
Oh, okay. Anybody left out? Okay, guys. So you are taking your test on Tuesday, right?
Right.
Good.
Sure.
Yeah, that's what I got the message from our section marcher. I mean, say Nina. Right? Okay. Choice. I don't mind. So let me do one thing. Let me continue with my syllabus first. And before I start my syllabus, I just want to ask you, do you have any doubt? Because I'm pretty sure you might have gone through the syllabus of the first test. If you have some doubt, I would be happy to clear your doubts first. And then after we can start with the next method of solution of differential equation. So any doubt? I'm pretty sure Margie will be having some doubts.
Why do you think that?
You have any doubt, Margie?
I did, but I guess like now that you went through the practice, or I realized like a lot of the notes are part of the practice test, so that isn't as bad. And I feel like if I could like send you the homework beforehand, then that would be helpful, or at least the ones I don't know, or the ones I'm not sure if I did right. Okay. Any other guys? Gage, Salomon, Ismail, Nina. If you have some, you can ask.
I
Yes.
actually do have a quick question. So I was looking at the practice test number 3.
Number 3, what is that?
It's asking y equals 1 over x squared plus c is a one parameter family of solutions of an ODE y prime plus yx or 2xy squared equals 0. We have to find the solution of the first order given the conditions. And I was just unsure what the answer actually was in your notes. I wasn't sure if the answer was just the domain that they shared or
Both.
the value.
Both.
Okay.
Both. First of all, 1 over x squared plus c. So I used the initial condition, and then after I found that value of c, because again, let me remind you, the purpose of initial condition is to get particular value of your constant c in the solution. Once you get that one, then after I figured it out, the domain of my solution. So that solution, because if I plug the value c equal to, I think in the first initial condition, c was 1. Am I right if I'm not wrong?
Yes, sir, it was -1. But
y equal to 1 over x square minus 1. If you
Yes.
plot the graph of the function y equal to 1 over x square minus 1, negative 1 and 1, these are the points for which your function is not defined, because that will make your denominator 0, means value is infinite. So at these 2 points, the function is not defined. So if you plot the graph of the function, you're going to get some graph like this. You're going to get something like this. Look at what you're going to get the graph like this. All of you can see this one, right? Yes or no?
Yes, sir.
Yes, sir.
Okay, so for y equal to 1 over x square minus 1, because my function is not defined at plus or minus 1, that means I have to exclude these 2 points from the real line. That means r minus plus or minus 1, that is the domain of y. That means I can write negative infinity to negative 1, then I have to open interval. Then I have to use negative 1 to 1 open interval, and then 1 to infinity. So that is the domain for my solution operator. Just the solution operator. I am not talking about the initial value problem, just the solution. But if I include the initial condition, so y equal to 1 over x square minus 1, of course, that yx is not equal to plus or minus 1. That is the solution of, what is the differential equation I gave it to you? Give me the differential equation in problem 3. Nina.
Was it the y equals 1 over x squared plus c?
I
And
want,
then c equals negative 1? Is that what you're
no,
asking?
I want the differential equation. Read the first line.
The first line. Yeah, it's y equals 1 over x squared plus c.
Go ahead, read the full example.
Y equals 1 over x squared plus c is the one parameter family of a solution of ODE y prime plus 2x y squared equals 0.
Correct.
Okay.
Excuse me. So y prime plus 2xy equal to 0, right? You said?
Y prime equals 2x y squared equals 0.
Y prime equal to 2xy square?
Yes, equals 0.
Y prime equal to 2xy square or y prime plus 2xy?
Plus y prime plus 2x squared equals 0.
Y prime plus 2x square equal to 0. That makes sense. So for this y prime plus 2x square equal to 0, if I use the initial condition, what is the first initial condition? Y at 0 equal to 1.
Y2 equals 1/3.
Equal to 1. So if I include this initial condition, y2 equal to 1 means when x is equal to 2, y is 1. So x is equal to 2, y is equal to 1. So that would be this point. X equal to 2 and y equal to, x equal to 2 and y equal to 1. Look at my finger. That is this point.
Sir, it's 1/3, not 1.
It's 1/3, what it may be. So 2 and 1/3. So that is this point. Am I right? And this initial condition lies only on the last portion of your general domain, that is 1 to infinity. This lies in 1. So whenever you're looking for the value of the domain of the initial value problem, at that time you have to make sure that you are taking only that portion from the whole solution in which your initial condition lies. So for this one, the domain of your initial value problem, that is equal to 1 to infinity. You need to write like this. Domain of the initial value problem is equal to 1 to infinity. Does it make sense?
Yes, sir. So that's the answer.
Yes. So you have to first find C, find the domain. Then after, use the initial condition. Again, find the domain. And then go for the common domain.
Yes, sir. Thank you.
No problem.
Wait, so when you're asking for both the domain and
I can't
the
see you.
solution,
I can't see you.
sir, I'm still on my phone.
Why? It's been 3 days. Fix this problem.
I told you, because I'm not going to spend $1,000 on a laptop that's not worth $1,000 when I'm getting a new one in a month.
So you don't have any desktop or like this at your home?
I don't have a desktop. All I have is a broken laptop.
Okay, so I don't know how can you manage with just your cell phone, very small screen. I don't know. That's fine.
Yeah, I mean, I'm making do. That's what I did all spring semester too.
Oh my gosh. Go ahead.
But when you're asking for the solution, and hold on, I'm gonna pull up the problem real quick. The exact same problem that she was just asking about. So find the solution of the first order of this differential equation with the given initial condition. So is it one solution using all 4 of these given initial conditions, or is it like a solution for each individual one because the constant varies? So
Hopeless question. Hopeless question. If you use the initial condition, that means your value of C will be different. Once the value of C is different, that means 1 over y square minus C. That C is different. That means every time you are going to get different domain. And
okay, so we're just finding.
Let me finish, please. If that domain is different, so naturally that would be affected. Another thing is, what is your initial condition? Every time your initial condition is also different, right?
Mm-hmm.
Yeah, so that's why every time your solution will be different. Now go ahead.
Well, so all we're needing to find is C in the domain, because when we find C, that's the solution.
Yes.
Okay. Yeah, that's all I was wondering on that one. And also, I was wondering if maybe we could go over another one of the separable variable problems. Because
I solved already 3 examples. No, out of 6, I already solved 3 to 4 examples. You want me to solve all the examples? That's not going to happen.
That's when I wasn't in the class yesterday.
That's not fair. Why you were not there in the class?
Because the Zoom code was messing up because I was using the one before you reset it to the different one.
Dr. Dimple, did you upload the lecture from yesterday to YouTube?
Yes, I
Because
did.
I think it would be on there. So could you maybe send us an email with a link to your YouTube channel? Because that way we can. I think the separable variable problems were at the beginning of that lecture.
So nice of you. Yeah, everything is there. Hostetler, just Hostetler, right? William?
Yeah, I mean, if I could
just go through the full lecture, because I upload all my lectures on YouTube every day. So if you have some doubt, if you are now onwards, guys, please look at me. Please try to listen to me carefully. If you have any doubt, just try to go through YouTube and try to start the video. You are going to get complete lecture, whatever we have been discussing over here, or we have discussed over here, exactly same thing. A whole 2 hours class, again, the 2 hours lecture you will be getting over there. So you can solve lots of your problems once you go through this YouTube lecture. And that's the purpose, main purpose why I install, because you know it's always time consuming for me, because Zoom downloading, then after I install, I save over here on my file, then after install over there, and installing on YouTube for 2 hours lecture takes always it takes more than 20-25 minutes or sometimes 30 minutes. Yesterday it took more than 40 minutes for me to upload, because it's a big lecture, big file. But I am putting all my lectures over there just for your convenience. Anyway, because will he put this request, so let me do one thing. Let me solve one example, right? But now, if you have some doubt like this, if you are missing some of the things, just go through again the lecture so that you can't miss anything. Separable variable, I don't have that assignment with me. Nina, will you please give me one example? First one, second one, something like that.
Separative variable. I think we did this one in class. Dy over dx.
Dy over dx, okay.
Equals y squared minus 4.
Y squared minus, that already we solved. Let me go for the next one, another one.
Okay, B, it's e raised to the 2y minus y.
E raised to the 2y minus y, yes.
Times cosine x dy dx.
Cosine x dy dx.
Equals e to the y.
E to the y.
Times sine 2x.
Sine times 2 times. Is it like this? Just look at here, double check please.
I can't see it, sir. That's the wrong part.
Is it okay now?
Down a little bit, down a little, other way. Yes, sir. That's right.
Okay.
And then the parameters are y of 0 equals 0.
Okay, that is called initial condition. Y at 0 equal to 0, not the parameter. Okay.
Sorry, sir.
Okay, that's fine. Will, can you see me?
I can see you, sir.
Okay. So is it not possible for you to start the video on your cell phone?
I can, but I would only have one hand because I would have to hold my phone up at my face the entire class.
That's fine. Oh my gosh, I'm sorry about this. Okay, so let me solve this one. That's really good that at least you can see me. We are looking for the separable variable over here. You can see here, I have e to the power 2y minus y on my left side and e to the power y on my right side. So what I'm going to do, I'm going to divide by e to the power y, both the sides, so that e to the power y will get cancelled out from the right side. Simultaneously, I would like to divide by cosine x, so that cosine x will get cancelled out from the left side and cosine x will be there on right side. So that is the another advantage, and that's how we can remove all x's from left side and all y's from right side. So you will be getting this something like this if you can look at my page.
Hold on, sir, I can't see where you wrote it. Like you're like in the middle of notes.
Other guys,
There you go.
other guys can be able to see me.
Down a little more. All right.
Okay, now e to the power 2y divided by e to the power y is e to the power y minus y e to the power y and dy, that is equal to sine 2x divided by cosine x and dx. Yesterday I just spoke the whole solution whenever I went through all your practice test assignments starting from the beginning, in the beginning of the class, if you remember. Right, guys? So finally you are getting like this, and you can see here that I separated my variables. I have one side y and other side x. One side y and other side x. So now I can go for the integration. So integration and plus c, because the variables are already separated. Only then after you can go for the integration for separable variable method. Integration, term by term integration will work over here. So e to the power y is e to the power y. Second term is y e to the power y dy, and that is equal to sine x. I would like to write as 2 sine x cosine x by using trig formula, and dx plus c. So cosine x will get cancelled out. 2 is out. Integration of sine x is negative of cosine x and plus c. So I'm getting my right side integral. Let me do one thing. Let me solve this problem and I will send it to Nina so that she will forward that page to all of you. Okay. Now, for left side, it is e to the power y, and we have to use the integration by parts. So here it is y and e to the power y minus y is your u and e to the power y is your v. So y e to the power y, first u times integration of v minus derivative of u and integration of v. So it is e to the power y, that is equal to negative 2 cosine x. I think we solved this example yesterday too. Am I right, guys? E to the power y minus y e to the power y plus e to the power y is equal to negative 2 cosine x plus c. And this implies that e to the power y and 2 e to the power y is 2 times e to the power y minus y e to the power y is equal to negative 2 cosine x plus c. So this implies that e to the power y common and 2 minus y is equal to negative 2 cosine x plus c. So this is the solution. Look at over here. This one is the solution. Again, I'm going to take the picture and send it to Nina. Now, you know how to use the initial condition, right? Yes or no, guys?
Yes.
Yes, sir.
Okay, how to use the initial condition, that you know. Okay, so I think let me leave it over here, right? You can use the initial condition, otherwise, since I would say, where is it? Y at 0 equal to 0. So when x equal to 0, y equal to 0. X equal to 0 means cosine 0 is 1. So negative 2 plus c. Y equal to 0, e to the power 0 is 1. 2 minus 1, so it is 1. So naturally my c is equal to 3. So just go back and plug this value of c. So e to the power y, 2 minus y equal to negative 2 cosine of x plus 3. So that is my general solution. Look at here. I just went from bottom to here in this block, and this is the solution. This one is the solution. Look at my finger. So this is the solution. Is it okay, guys? Is it okay?
Yes, sir.
Yes, sir.
I got C equals 4.
What is the initial condition? He gave me y0 equal to 0.
Yeah, that's what did you get as the actual equation, like the answer? Not like C, but the actual differential equation.
C gave me e to the power 2y minus y cosine x divided dx equal to sine 2x, e to the power y sine 2x.
Oh, after we solved it down, that's what I mean. Like after we solved that. Like took the integral of both sides.
Let me take the picture and send it to you, and then
All right.
Okay.
Because I might have integrated it.
Yeah, so let me send it to her, and then you can compare. Did you get it, Nina?
Not yet, sir. I haven't gotten it.
You will get it soon. Yeah, yeah. You got it.
Not yet. Oh, yeah, I just got
it. It says. Okay. Okay, guys. Any other doubt? Any other doubt?
Sir, I just have one quick question on phase portraits. I understand how to get, oh man, I don't know my paper now. I understand how to get to the actual diagram in itself, but when you're asking attraction or repulsion and stable and unstable, what does that mean?
Your solution is stable and unstable. Whenever, yeah.
When the graphs come together, I could see what it means by
graphs. Yeah, arrows. Suppose the upper function is increasing. Suppose you have 2, 3 domains. In the first domain, suppose function is increasing. The second domain function is decreasing. So increasing means you are getting the arrows upward. Decreasing means you are going to get arrow downward. So that means both are in the opposite direction. So that's why it is called the repeller. Means your solution is unstable. Yeah. You don't know about this thing, but whenever you are working with the differential equation and the dynamical system, at that time stability makes a big difference in the solution. Stability is one of the portions, and that makes a big difference. You don't know about the stability and all the definitions, but people are working on that. Solution stable, that means sometimes your small change in your equation will make the whole solution. Just like cardiogram, it makes everything different. It changes very frequently. So that is called unstable. It moves very frequently, just like zigzag form. But solution stable means it just remains the same, constant like this.
So we have to identify those points where y.
You have to choose the points from each different domains. Plug that point in your divide dx y dash equal to f of xy, and if you are getting greater than 0, it is increasing, less than 0, decreasing. Other way around, suppose your function is decreasing in the first domain, and that means you are putting downward arrow, and second domain it is increasing, means you are putting upward arrow. So in that case, both of them, they are approaching each other, both the arrows, and that's why it is called the stable solution. Right.
So we have to identify those points. So in example 1, we have that y equals plus or minus 0 and y equals 0. So we have to identify if it's stable or unstable at y equals 1, y equals 0, and
no, not at y equal to. You don't have to identify the critical points. You have to choose any point in between the domain. At y is equal to 0 is a critical point. That means it won't give you anything. Suppose I have critical numbers 0, 1 and -1. So 0, 1 and -1, right? If I have 0, 1 and -1, that means I will be having the domains like this. Y equal to 0, y equal to 1 and y equal to -1. So first domain is like this. Look at what here. The first domain, that is -infinity to 1, sorry, positive infinity to 1, infinity to 1, then 1 to 0, then 0 to 1, then 1 to 0 to -1, and -1 to infinity. Agree?
Yes, sir. I get that part.
So wait. So you are supposed to choose the point from this domain. Suppose you want to choose the domain point from the first domain. First domain is 1 to infinity. 1 to infinity. That means you can choose 2, 3, 4, but don't choose 1. 1 is your critical number.
Right.
Go ahead.
So that's I understand that part. So I picked 2, 1/2, -2 and 1/2. I mean, I'm sorry, negative.
-1/2 and 2. Negative.
Right, and I got that part, and I was able to like choose the graph part, but I was just confused on where do we identify like the stable, unstable. Where are we looking? Because
show it to me.
so like
yeah.
So right here.
No, not right there. Approaching. Look. Okay, I got your point. Okay. Suppose in the first one it is decreasing, and the second one it is increasing. Put the arrows like this. I can show it to just wait. Let me use the different pen. Okay. So here it is decreasing. Here it is increasing. So just put the arrows, and you can say that asymptotically stable. Like this. Look at here.
Yes, sir.
Okay. Just look at those two arrows, and then you can say.
Okay, so if the arrows are okay, now that makes sense. So it's stable between the two arrows, not at y equals 1.
Yes, between two arrows means yes, not at y equal to 1. No, between those two domains, your solution will be stable.
That makes more sense. Thank you.
Domains, because you chose the point for your convenience. You chose -1/2, right? Oh, sorry, positive 1/2 and 2. You may choose 3, you may choose 4, you may choose 1/3. So all those whole domain, this is stability. Stability will occur for the whole two domains. Are you getting me?
Yes, that makes sense.
For 1 point. 1 point you chose for your convenience, but that's a random point. That's not a fixed point. You chose 1/2. Suppose Elias, he chooses suppose 1/3, right? Margie, suppose she chooses 4 instead of 2, right? So all you guys are getting the same thing. So your stability of the solution, that is in the full domain.
Yes, sir.
Any other question? Yeah. Any other question? Any other question, guys? Okay. So I think you guys are good with linearity too, linear and nonlinear problems too. Let me remind you, linearity means whenever, Margie, what is the definition of linear differential equation?
It's only to the power of 1.
Don't say like this. Please give specific definition. Yes.
Well, isn't linear like the y is only raised to the power of 1?
That's it.
That's how I like look at the equation, remember it.
Suppose I have y times y dash, both power 1 then.
Yeah, but I guess like if I see that, then I know it's not to 1 because it'd be y squared.
No, it is y times y dash and both power 1. So
yeah, but that wouldn't work because if you like multiplied it out, it'd be y squared. So like in the simplest
it has to be there in the
form,
definition, right? Don't give me in a rough sense.
Well, in the simplest form, it should be raised to the power of 1.
Yes, anyone else? What is the definition, Ilyas? Linear differential equation.
Well, to start with, like Margie said, it's raised to the power of 1, but you also can't multiply it.
If you want to learn like this, then I think I'm not the right person to teach you.
And then
if you don't want to follow like complete definition.
You also have the P equals Q form. So you have to have to where
if you don't want to follow complete definition, I think I'm not the right person, and you guys are not the right person for right guys for me too. More than 20 times I spoke the definition. 2 times I wrote it down. If you don't want to memorize and if you want to work like this, it's not going to happen. Yes, any one of you? Just read the notes, class notes. Just go back, read the notes and give me the definition.
Sir, so linearity, a differential equation is said to be linear if the dependent variable in all of its derivatives appearing in the first degree and they are not multiplied together.
Right, so these 2 conditions should be there. So once you say the definition, that means you can say that 2 conditions are there. One is dependent variable and all its derivatives must appear in the first degree. Understood? And they are not multiplied together. So this way you can say like this. I don't want exactly word to words, but at least you have to have 2 conditions with you. Don't give me rough things, because if you are not particular, you are going to mess up your example too in your exam too. That means you are going to lose your points and then you'll blame me. I don't want that thing. I told you we are going to use this thing so many times. In chapter 4, we are going to learn the higher order differential equation. Again, I will be dealing with the linearity. Don't take this subject easily, guys, please. I don't want to create any tense situation, but I told you very first day that if you are working with me, you will really enjoy this thing. But if you don't want to work with me, probably nobody can help you out. At least not me. Any other doubt? Just excuse me, please. Sorry, guys. Feeling good. Yes, any other doubt, guys? So linearity means these 2 conditions are satisfied. The general form is dy by dx plus py equal to q. Once you have this general form, then after you can go for the integrating factor y equal to e to the power integration p dx or px dx, you can say. Once you find the integrating factor, I told you that if you are getting e to the power 2ln y or e to the power, 2ln y, then use the ln property first, write e to the power ln of y square, because ln of a to the power b is b times ln of a. You have to use this property before you proceed further. That means you are getting exponential function and logarithmic function. They are the inverse of each other. The effect nullified, so it will get cancelled out. And you are getting e to the power, so you are getting simply y square, just as an example. And then after you can go for the general solution. General solution is dependent variable y multiplied by the integrating factor is equal to integration right hand side qx, whatever you are having, that is multiplied by integrating factor and dx plus c. And then solve your right hand side, go for the integration, and that will give you the answer. If you are giving some initial condition, don't ignore it. You can apply that initial condition at this level and try to fix your value of c, and you are going to get some particular solution. Good.
Sure.
Yeah.
So
Please,
the way
that.
Huh? Can you hear me?
I don't want to. Don't speak. Don't speak in the air, please. Let me finish my sentence first. Go ahead. Go ahead.
On the exam, so you said you're just going to give us like set amount of differential equations and not really differentiate which ones. So I'm just wondering, so we're going to have to learn which one we have to use, like separable variable, linear, nonlinear, etc.
Correct.
Okay.
Yeah, because in general, you guys will be provided the bunch of differential equations and you are the right person to figure it out which method is to be implemented for the given differential equation. That is the only hardest part, because once you identify the method, then after I think the solution is quite simple, because you don't have to do any, I'm going to say, you know the method and you can solve it very easily. But the main thing is to identify the nature of the differential equation, which method is proper, is particular for that one. Yesterday, if you look at the video or yesterday's class, you know that I gave you a couple examples in which, and mainly for that nonlinear differential equation and homogeneous differential equation, I solved just one example by both the ways. Just to let you know this thing, that one example can be solved by two ways, right? So suppose I would say that suppose Paul Mustaine, he's solving one example using nonlinear, and Nick Campbell, he's solving the same example using homogeneous. And if they are getting the same answer with right methods, I don't mind. Both are entitled to get the full points, right? But if I mention that use separable variable, in that case, you don't have any other option. You have to stay with separable variable. You have to stay with homogeneous. You have to stay with nonlinear. If I mention that thing, if I don't mention, choice is yours. But other way around, it's some little bit difficult for you to figure it out, this thing. And that is the main thing that we are learning this thing. And if you remember yesterday and day before yesterday, I told you the same thing, that please work hard and make sure that which method is appropriate for your differential equation, right? And only practice will make you perfect. So if you think that you can just go over the examples I gave it to you in the practice test and you are done, no. Of course, that will help you a lot, but that doesn't mean that that's enough. You know what I mean, right? If you are thinking to get A grade in this course, at that time, you have to put little extra efforts too. You can't rely only on the practice test. Practice test will give you different kind of examples, but to practice the examples, you have to solve some more examples too. Am I right, guys?
Sir.
Yes, sir.
Right? Will, did I answer your question?
Yeah. So there's going to be some where we decide which method to use, and then there's going to be some where you use separable variable or homogeneous.
Yeah, in general, I would say yes. But your exam is on Tuesday, so I may change my mind. But in general, I would say yes. Yes.
Okay.
If I, again, let me repeat, if I ask you particular method, stay with that method. If I give you just solve, means you can use any of the methods, but it has to be appropriate for that equation. Right?
All right. Perfect. Thank you, sir.
No problem. Yes, Solomon Harris, are you okay? Nathan Light? Nathan, speak something. You are very quiet, like Ismail.
What?
Speak something. You are very quiet.
Oh, I was just listening.
Okay. I hope you are good, right?
I'm great.
You're great or good?
Yeah.
Then you don't have any problem with our assignments and all other things, right? For this first test.
No, I'm great.
Sounds good. And Ismail, you are working, I know. Solomon Harris?
I'm good.
Will Hostetler, he is also working. I like your approach, guys. Good. Just work hard. And again, if you have some question, you can ask me. Paul Mustaine?
I do it. I just need more practice.
Yeah. Practice, that's the only thing. Without practice, you cannot survive for this subject. You have to spend lots of time. And very first day, I told you that if I'm teaching here for 2 hours, at least you need to spend 3 hours a day. Yes, Gage Levine. Are you okay? Gage. Smile.
Yes,
See, I like this fine smiling face. Good. Ilyas.
Yes, sir.
Are you good?
More practice, sir, but I think so. We'll get there.
Any question for me? Any question for me? Not so far. Okay, if you have any, let me know, okay? And then after, who is left out? I think our two girls, Nina. Yeah, she asked me lots of questions, 3-4 questions. I think she is good now. Am I right, Nina?
Yes, sir.
And who is the last one? Margie?
Yeah, I'm good.
Yeah, good, right? If you have any doubt, you can ask me, guys. Only thing is, whatever I taught you, just read that thing nicely. Don't give me the answer, just, I mean to say rough answer, please. Yeah, that's fine. So is it okay if we start the new article, guys?
Yes, sir.
Let's do it, sir.
Alex, I'm sorry, I forgot you. Is it,
Yeah.
Are you good?
I'm just a little more practice, but I'm starting to get it.
Okay, good. So I think, yeah, that sounds good. Almost we spent 45-50 minutes just for the revision kind of things. Yeah, I can give you some hint that you know that theorem 1.2.1 example number 5. Excuse me. Just go over that type of example. Then example number 3, you may get couple examples from verification. You may get couple examples from domain range and order, linearity. You are going to get 2 examples or 1 example from separable variable, 2 examples from linear or like this. Right? And heart is not here, right? Heart is in our section. Am I right, Nina? Heart.
Yes, sir.
He's been coming in and out.
Yeah, he texted me to tell me that he was having difficulties with his internet.
Okay, just do one thing. After our talk, just send the message to him that he can refer the video, okay?
Yes, sir.
But yeah, he sent the message just now to me. He said that he's facing some internet problem. Okay, fine. Just send the message to him.
Yes, sir.
Okay, guys. So I think let me continue with our next part that is called it's the next differential equation, right? Okay. So guys, yesterday we did the linear differential equation, and then after, yes, I forgot to explain to you the non-linear differential equation, y to the power n, that creates nonlinearity, divide by this one, and whatever you are getting over here, that has to be used. By doing these things, we are converting the non-linear equation to the linear differential equation in this form. Once you have linear, that means you can go for integrating factor, general solution, and then finally replace your u by your substitution, whatever you chosen for your substitution. And I told you that this is a nice example number 10, 2, and second one is, sorry, question 10, 2, yeah, this is a nice example. Second one is this one. Fourth one is also a nice example. So I like these examples, that's fine. Then after we went over the homogeneous differential equation, right? Homogeneous means powers are same in numerator and denominator. And the method of working is always consider y equal to vx. So dy by dx equal to v plus x into dv by dx, product rule. And v equal to y by x. Just plug the values over here. And after doing this thing, you are getting the separable variable. So always the homogeneous is converted in the form of the separable variable. And then you can go for the integration, right? Your calc 2 technique. Don't forget to plug the value of v, that is y over x. Same example will, yeah, that is for you. Same example, look at here. we solve for non-linear as well as the homogeneous, same example, and we are getting the same answer. And that's why I wrote it down, question 10.4 and 9.2. Okay, guys, and last part is the exact differential equation. I just want to teach you only exact differential equation today, not any more thing, and we'll stop once we are done with the exact and substitution, 2 methods, right? That will be the end of this chapter. And Tuesday onwards, we are going to start chapter number 3. Okay, exact differential equation. Whenever the differential equation that is of the form m dx plus n dy, when m is a function of x and y, n is a function of x and y equal to 0, then that equation is called an exact differential equation, m dx plus n dy. That is the general form actually. The sufficient condition, I told you I require calc 2 partial derivative only at 2 places. One is your theorem 1.2.1, existence and uniqueness. That's what we did last time, last time, day before yesterday. And sufficient condition for the exact differential equation, that is, this is your m, this is your n. So del m by del y, partial derivative of m with respect to y and partial derivative of n with respect to x. If they are same, that is called an exact differential equation. Without checking this thing, you cannot proceed further for the solution. You have to have this condition. You have to have this condition satisfied. First thing. But all of you, please look at me. Sometimes it may be possible that your equation that is of the form m dx plus n dy equal to 0, but this condition is not satisfied. Del m by del y is not equal to del n by del x. In that case, all of you please pay attention. In that case, we have to use some particular integrating factor. Multiply your given equation by that integrating factor, and then check your del m by del y and del n by del x. If you have chosen your integrating factor correctly, that new equation will become the exact. It will satisfy this condition. So there are 2-3 different methods of getting the integrating factor. Your book, or almost all the books, they say that integrating factor or choice of integrating factor is just trial and error method. You can use first one. If that doesn't work, go for the second one like this. But I will give you some particular technique. Yes, it is a technique because it is not mentioned in any of the books. I will give you some particular technique, and if you apply that technique, you will be approaching to the right integrating factor. Sounds good?
Yes, sir.
Yes, sir.
All of you are with me?
Yes, sir.
Yes, sir.
Good. So first of all, I would like to take a couple examples in which del m equal to del n by del x, this condition is satisfied directly. Then after, I will be taking the examples in which this condition is not satisfied, and we are going to find the suitable integrating factor and make this condition satisfied. Right? So that is the approach, or that is what we are going to do in today's class. Good, guys. Now, general solution of, once you have this condition satisfied, then after only you can go for the general solution, m dx plus n dy equal to 0. General solution is, just write your m function over here and n function over here. M is to be integrated with respect to x, n is to be integrated with respect to y. But we have some, whenever you are integrating your m with respect to x, always consider your y constant for this part. And for nxy, always consider your terms free from x. That means your nxy, suppose this different exact differential equation includes x and y. Just ignore your x and write down only the terms of y. There is a big theory behind it, how to get this equation, but we don't include our theoretical portion over here, how to get this general solution of the exact differential equation. So just accept this one right now. Is it okay? Just accept it. Okay, guys, my first example, look at over here. 5x to the power 4 plus 3x square y square minus 2xy cube dx plus 2x cube y minus 3x square y square minus 5y to the power 4 dy equal to 0. This is a function of x and y. Am I right? The first bracket.
Yes, sir.
So it is called m. M is a function of x and y and dx. Plus n is a function of again x and y and dx and dy. And that is equal to 0. So this equation that is of the type m dx or mxy dx plus nxy dy equal to 0. Am I right? Mxy dx plus nxy dy equal to 0. Yes or no?
Yes, sir.
Yes, sir.
Right, guys? Good. So my first task is to verify whether del m by del y equal to del n by del x. Don't look at the notes from your canvas right now. I just want you guys to work on this one. What is my del m by del y? Or you guys, let me ask to you guys, okay? Nick Campbell, just give me del m by del y. Partial derivative of this function, first function with respect to y. Go ahead.
So can you scroll it down a little bit, sir, the bar at the bottom? Thank you. So the
Wait.
can I go ahead, sir?
Okay, go ahead.
So you said just for m of xy, correct?
Yes. So del m by del y. All of you, please pay attention to him. Go ahead.
So the 5 times x to the 4th is treated as a constant, so that would go to 0.
Correct. Because you are taking partial derivative only with respect to y, means x is constant. So first part derivative is 0. Correct.
Yes, sir. And then it would be 3x squared times 2y. So that would simplify.
Because x is constant, x is treated as constant. So 3x squared is constant. Derivative of y squared with respect to y is 2y. Is right. Next.
And then minus 2x times 3y. 3y squared, excuse me.
Correct. 2x times 3y squared. So all of you, please write down as he spoke that del m by del y equal to, all of you, please write down del m by del y equal to, yes, what are you getting? 3x squared 2. So 6x square y minus 6xy square. Agree? Agree of you? Will?
I'm trying to follow it, sir. I'm writing down.
You say one more.
So 6x square y minus 6xy square. That is my del m by del y. Agree? Ismail?
So, sir, for the second one, doing the partial derivative, you do it with respect to x.
I'm not getting you.
So what we were just doing, we were doing the partial derivative. We do it with respect to x on the next one.
For the next one, yes. Go ahead.
Okay, so the first one's like with y, and then one's for x.
Yeah, so what is the partial derivative of this one? Look at my cursor with respect to x.
Yeah, so it'd be 3x squared y.
3?
Or 6x squared.
6x squared y. Correct. Who is answering right now? Ismail? Who is there? Who is answering this thing to me?
Which one am I answering?
Yeah. Whose voice was there?
Oh, that was mine, sir.
Who?
Alex.
Alex. Okay, sorry. Yeah. So you are right. Next is Alex.
Next is 6x y squared.
6x negative. Don't forget
Or
negative.
-6x.
Negative 6x y square. And finally, negative 5y to the power 4 is?
That's 0.
0. So what are you getting here? 6 x square y minus 6 xy square. Agree?
Yes, sir.
Is it both of them are same or not?
Yes, sir, they are.
Del m by del y equal to del n by del x. Both of them are same, right?
Yes, sir.
Yes, sir.
Good. Both of them are same. Look at over here. And that's why, see, you need to write like this. See, it's very specifically mentioned over here. Del m by del y, del n by del x, x constant, y constant. I wrote it down even derivative, partial derivative 0. Everything I mentioned, and they are same, see? So therefore, I put the block over here that del m by del y equal del n by del x. That means given differential equation is an exact differential equation. Nobody, I don't leave any room for anybody to cut my point. So now I can go for the general solution. Right? So Margi, what is the general solution?
Like the definition of it?
What is the general solution? General solution integration m dx. Your m was this one. Agree?
Mm-hmm.
Integration of m dx. Look at here. This is the general solution. Yes or no?
Mm-hmm.
Are you getting me or not?
Yeah.
I have a question.
Yes, go ahead.
So you said m of yx is in terms of dx. How come we did it of dy when the left side was m of y? The m.
I'm not getting your question. Repeat, please.
On the example, you said the 5x4, that side was in terms of y, but we labeled that section as m parentheses xy. Why are we doing it in respect of y instead of x?
That's the method of solution. I told you that there is a big theory behind it, that why we are taking del m by del y and del n by del x is a theory. And that's why I told you that just accept it. Why this one? You are asking me right now, why this is the sufficient condition to get the exactness of the equation. You are asking me this thing. Why del m by del y equal to del n by del x is the sufficient condition. Am I right? Why this one with respect to y, not with respect to x? Why second one is with respect to x, not respect to y? That's what you are asking me. Am I right?
Yes.
Yeah, so that's a theory. Right now, I would say just accept it. I can give you the big theory, but that's not in the syllabus and it's time consuming. It will take at least 15-20 minutes to prove that thing.
Okay.
I can give it to you, but right now I would say just accept it. So del m by del y, just accept it. Del m by del y. Okay, guys? Margi, Margi, go ahead. Margi, or what? Oh my gosh. I was asking you for the general solution of this equation because we ended up with del m by del x, del y equal to del n by del x. Our sufficient condition was satisfied. So now we are looking for the general solution. So you are plugging this value over here, keeping your y constant. Am I right? And that's where we ended up. And then Mustan, he asked the question in between. So now go ahead. Now continue.
I need to work on that.
It's simple, Margi. Look at here. If you plug this value here, look at me, all of you. If you plug this mxy over here, right? We don't talk about the second part. We are just talking about the first part. So y constant. That means we are integrating with respect to x. What is the integration of 5x to the power 4? Give me. Margi. 5x to the power 4. What is the integration with respect to x?
That ended up being x to the power 5.
X to the power 5, right? And 5 and 5 will get cancelled out. So it is x to the power 5 divided by 5. 5 and 5 will get cancelled out. So you are getting just x to the power 5. That's what you mean, right?
Yeah.
Okay. Now, what is the integration of the second term with respect to x? 3 and y is constant. So just pull it out because your y is constant. So y square is constant. Integration of x square is?
So that ended up being 6y squared.
So it is x cubed divided. No, it's not 6. You are taking derivative. I'm asking you integration, please.
Oh, integration.
Oh my gosh. So x square integration is x cubed by 3. Am I right, guys? All other guys are following me or not?
Yeah, so
So it
that'd
is
be
now 3 will get cancelled out and C is getting x cubed y square. Agree?
Right.
Yes, sir.
Margie, are you getting x cubed y square?
yeah, that's what I got.
Okay, let's go for the last term. Bless you. What is the integration of negative 2xy cubed with respect to x?
So it'd be x squared y cubed.
X squared y cubed, because integration of x is x squared by 2. 2 will get cancelled out. So don't forget negative. Negative of, you have to speak negative.
Oh, yeah.
Negative of x squared y cubed. Right?
Yep.
Cubed. Okay, so that is my first part. Now, my second part. Terms free from x. Do you think that my first term involves x? Yes or no? Yes or no?
It does.
Right? So remove this part. Don't count this one. Do you see my second term involves x?
Yep.
Don't count this one. Remove it. Because it says that terms free from x. You are supposed to take the integration for only those terms of n in which x is not included. Do you think my last term includes x?
No.
No. So what should be there for nxy here?
Y to the 5th.
Y to the... No, my nxy. I'm not asking you integration. What should be my nxy here?
Oh, 5y to the 4th.
Wrong.
Negative 5y to the 4th.
Negative 5y to the power 4, right? You got it, Ilyas. Negative 5y to the power 4. All of you are getting us?
Yes, sir.
Okay. So negative 5y to... Ilyas, go ahead now. What is the
And
integration?
then the integration would just be negative y to the 5th, correct?
Right? Negative y to the power 5th. Sum it. That's your answer, right inside C. Am I right?
Sir, we had a lot of constants cancel out in this example. Will that always be the case, or is that just the way that the problem worked out?
Depends on the example.
Okay.
In this example, you have it, but that will not be the case for all the examples. Right?
I have a question, sir.
Yeah, you can go first.
All right. So why did we take the partial fraction of it, or like the partial derivative, if we just ended up integrating it later?
Who is there? Who is asking me?
Alex.
Alex. Yeah. What's the question?
Why did we take the partial derivative if we ended up just...
Oh my gosh, why you guys asking me the same question? Mustaine, he asked me the same question, that why it is del y by del x, del y by del y partial, it's a method. It's a solution method. I told you, just accept it. Okay. Otherwise, the other option is I can teach you the whole theoretical portion. But right now, I would say just accept it.
Sir, so really the exact differential equation is as simple as just taking the partial derivatives and then integrating it and combining them.
Yeah, if this condition, equality condition is satisfied.
Oh, okay, I get it. So, okay. That answered it. That answered it right there.
Okay. If that sufficient condition is satisfied. Okay, guys. So, solve the same example by homogeneous method also. See here, I give you the hint. I put the note over here. Solve the same example by homogeneous method. Why? Why I say it like this? Look at the equation. Stop this. Okay. See, what is the highest power here?
4.
4.
4. What is powers? What is the power here?
Yeah.
4.
4, right? Because in multiplication, so 2 plus 2 is 4. What is the power here? 1 and 3?
4.
4. So all the powers are 4. Agree? Here.
Yes.
Yes, sir.
3 and 1?
4.
4.
2 and 2?
4.
And here it is?
4.
Right? So all the powers are 4 over here too. So if you write dy dx, if you send this term to other side And then if you divide by, if you write divide dx will be this term divided by this term. And powers are 4 everywhere. That means same equation can be solved using homogeneous method too. Agree, Nick?
Yes, sir.
Right? Same equation can be solved using homogeneous y equal to bx method too. I have not solved that, yeah, homework. It's lots of work. But it can be solved, yes, 100% I'm sure. Second example. Simplest one. This first and second, both examples, they are from your practice test. Margie, again, the help to you. Okay, example 11. Okay.
So for the next exam, are we supposed to do, is there like another practice test and then we should do 11 added on to that?
Yes, this 11 plus another practice test, both. For the second exam. 2x by dx plus x square minus 1 dy equal to 0. Del, this is my m, and del m by del y is 2x, del m by del y is 2x, exact differential equation, integration 2xy, y constant, and here terms free from x. So first term involves x, -1 doesn't involve x. So let me write just -1 over here. Look at here, guys, it's x square minus 1. X square involves x, but -1 without x. So write -1x, -1 times dy, and see integration. Here y constant, so 2y constant, x square by 2, 2 will get cancelled out, so x square, and y. Minus integration of 1 with respect to y is y, equal to c. This is the answer. Simple. Simple.
Yes, sir.
Yes, sir.
Okay. Now, second part is the equation reducible to the exact form. Equation reducible to the exact differential equation. Reducible, I mean to say, it is not an exact, means sufficient condition will not be satisfied for some of the examples. Whenever the sufficient condition del m by del y equal to del m by del x is not satisfied, in that case, we have to use this integrating factor. This is called integrating factor. I am going to provide you right now just 2 integrating factors. Actually, there are 4 different type of examples. But I would like to restrict only up to 2 integrating factors just to make your life easy. So equation reducible to an exact form. For the equation m dx plus n dy equal to 0, look at here, guys. All of you, please pay your full attention and look at the screen. I am writing del m by del y minus del n by del x. Whatever function you are having over here at your right of the bracket, right side, this n, divide by this n here. Second part is del n by del x minus del m by del y. So n is here, divide by m. Let me start with the first part. If 1 over n del m by del y minus del n by del x is a function of x only, if you find this one, find first this difference and then divide by your n function, and if you are getting just x, all your y's are removed. All your y's are cancelled out. In that case, if it is simply a function of x, your integrating factor is e to the power fx dx. Whatever the function you are going to get, that is your, actually, this is your fx. It's a function of x only, say fx, means this is your fx. This part is your fx. So whatever you're getting, this calculation, just take the integration exponential to the power integration fx dx. That is your integrating factor. Suppose you are not getting, you are getting function of x and y over here. It's not just fx. Try the second one. That's what your book say. Your book says. Try the second one. Del m by del y, del n by del x minus del m by del. If this is a function of y only, suppose gy. So this is my gy. Then integrating factor is e to the power gy dy. Every time, my question is, every time do we have to check both of these conditions? And if suppose first one is not working, I can go for the second one or vice versa. No, I don't like that thing. Why to create the confusion? Why to make our life more miserable? And why to waste our time? I will let you know this technique. Again, that technique is not given in the book, so please pay attention. But if you apply my technique, it is applicable to all non-reducible equation reducible to exact form, all exact differential equations. Just keep in mind this thing, right? Good. Good. Let me take the first example. Xy cube plus y dx plus 2x square y square plus xy to the power 4 dy equal to 0. Agree?
Yes, sir.
Yes, sir.
Good. So this is my mxy and this is my nxy. Don't forget these two, please. Otherwise, you will be wrong, because that is usually your habit to ignore the constant or the plus or minus sign. That is your habit. Your habit means student community generally. And that's why you guys are wrong. Don't do this thing. Anyway, what is my del m by del y? Margie, what is my del m by del y?
Why do you always call on me?
Why? I'm calling everyone. If you don't want to answer, see me. I will not call you.
Yeah, I'm just wondering why you always call my name specifically.
It's not specific. If you don't want to answer, that's fine. It's not specific. No, all are equal for me. Okay. Ismail, would you like to give the answer? Ismail.
Oh, can you hear me?
I can hear you. I can hear you. Please go ahead. What is del m by del y?
Oh, it's gonna be xy cubed plus y.
Del m by del y. So xy cube plus y is your m. What is the partial derivative of m with respect to y? Because first of all, we need to check the sufficient condition del m by del y. So what is our del m by del y? Are you following me, Ismail?
Well, yeah, you said you just take the derivative with respect to y.
Mm-hmm.
All right, so it's just gonna be y cubed plus y, right?
Y cube. What do you say it? I'm not getting you.
For question 3, I mean question 11.
Question 11.3. Xy cube plus y dx, that is my m, and 2 times x square y square plus x plus y to the power 4, that is my n. And first of all, so it is of the form m dx plus n dy equal to 0. So del m by del y, because we need to first check the sufficient condition, that equality condition. So that's why we require del m by del y and del n by del x. So what is del m by del y?
Wait, sir, I think I'm getting a little confused.
Nick?
So, sir, the del m by del y would be 3xy squared plus 1.
3xy squared plus 1. That's correct. Right? Ismail, are you getting us?
Or not?
Okay, yeah, I'm following.
Okay, derivative of this one with respect to just y means x is, and so it is 3xy squared plus 1. Okay. Then, Alex, what is the derivative of this second part, n, with respect to x? Yes. Will, would you like to take this one?
No.
No.
I'm struggling a little bit with this.
I'm asking you just the partial derivative of this function n with respect to x, means your y is constant. So y square is constant, 2 is constant. So 2y square is constant and derivative of x square is?
It'd just be x cubed since the 2 cancels
No,
out.
no, 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 no. You're finding partial derivative, not the integration, please. So what is derivative of x?
Oh, that's just 2x.
2x, right? So 2 2s are 4, xy square. That is the first term derivative. Am I right, Alex? Alex?
Yes, sir. Sorry, I was muted.
Will, is it okay?
Yeah, it'd be 4x y squared.
4xy square. Okay, then what is the derivative of x with respect to x?
That'd just be 1, so it'd be 2.
1, so it is 2. And now finally 2y to the power 4. What is the derivative of 2y to the power 4 with respect to x?
Well, since it's a constant, it'd be 0.
Correct, you got it. Nice. Right? So your left hand side was, now look at over here. Your left hand side was 3xy square plus 1. Your right hand side is 4xy square plus 2, del n by del x and del m by del y, and they are not same. Not same. Right? That means given differential equation is not an exact differential equation. Agree, guys?
Yes, sir.
Given differential equation is not an exact differential equation. That means we need to find the integrating factor. Now look at here, guys. You can use trial and error method, as I told you, that any one of these two methods, and suppose first one is not working, you can go for the second one or vice versa. But what I would do is, I would first choose this one, 1 over m del n by del x minus del m by del y. Why? The second method, second part I would like to choose first. Why I'm choosing second first, not the first one? The reason is, out of these two functions, which one looks like a bigger function? This is my one function, this is my another function. Which one looks like a bigger function?
N.
N, right? That means which one is a smaller function, other way around? N. Am I right?
Yes, sir.
Divide by your smaller function.
Okay.
Divide by your smaller function. If you go back over here in the formula again, my smaller function appears over here for m. Agree, Ilyas?
Sorry, sir. Could you ask that again?
I said that for given m dx plus n dy, try to compare your m and n. Whatever the function looks like a smaller function, always go for that division. Here my m looks like a smaller function, so I would like to go for division by m. And division by m appears here. It's not here. It's here. That's why I would like to go for this one as a integrating factor. Let's try.
Okay.
Try. Are you getting me now, Alex, Ilyas?
Yes, sir.
Gage?
Yes, sir.
Nina?
Yes, sir.
Nina, where are you?
Yes, sir.
Okay, good.
Sir, is this correct, what I have?
I can't see that one.
What's circled?
1 over, we are working on it, please.
Okay.
I need to explain to everyone. It looks like correct, but let me just work with the first problem. Okay. Now look at here, guys. I would like to work with this one because this function looks like a smaller function. So let me write it down over here, xy cube minus y. Now you don't have to take this, you don't have to count this one again because already you figure it out here in your first partial derivative. Look at here. So del n by del x stands over here at the first level. So use the same factor, 4x square y plus 2 here and minus sign, and then 3xy square plus 1 here. Because this minus sign is, you can put the bracket or you can multiply this minus sign for both of these functions. So you are going to get -1 here. This 4x, look at here, guys. 4xy square minus 3xy square. So 4 minus 3 is simply xy square. 1xy square. 2 minus 1 is plus 1. So xy square plus 1. Agree? Xy square plus 1. Look at here. My last line. Xy square plus 1. If you take y common from the denominator, you are getting xy square plus 1 in the denominator too. Agree?
Yes, sir.
Yes, sir.
Xy square from denominator. That means I'm cancelling out my numerator and denominator common factor, and I'm getting just 1 over y, and 1 over y is just a function of y. Look at here. 1 over y is a function of y, and that's what my theory says, that this one is a function of y only, means no x is there. That's what I'm getting here. That is just simply y, no x is there. Agree?
Yes, sir.
All of you agree with me or not?
Yes, sir.
Girls, okay. All boys?
Sir.
Yes, sir. 1 over y.
Say again.
Yes, y.
So here it is 1 over y. Now, my integrating factor is e to the power gy dy. So whatever I'm getting over here, this is my gy. I told you, plug this value here, e to the power gy dy. So e to the power 1 over y. 1 over y means ln y integration. So exponential function ln gets cancelled out, and that means you are getting simply y. So your integrating factor is y. Now, don't write anything, pay attention here. Please look at me. This is your y. Once you have your y, see, I put big arrow over here. Look at here. It goes like this. It goes like this. Multiply your given equation by y. So method says like this. Please, guys, look at me. Once you find the proper integrating factor, multiply your given equation by that integrating factor, and 100% that will make your new equation an exact form, an exact equation. So you don't have to check over here. If you are confident that whatever calculation you did, that's right, just multiply over here by y. So here you're going to get xy to the power 4 plus y square. Here you are going to get, oh, this one is bothering me. Let me just take it down somewhere here. Okay. So, yeah. So here 2x square y cube plus xy plus y to the power 5. Right? So if you write like this, that means you're going to get a new equation. Ooh. Oh my gosh, I think I missed that part. Probably I wrote it down in separate another page, and I forgot to take the print out. Okay, let me write it down for you guys. I can do that thing for you. Just wait. Yes, Annie?
No.
Guys, let me continue with this. Multiplying star means your given equation by the integrating factor. Your equation was this one. So therefore we are getting, so we have xy to the power 4 plus y square dx. If you want, you can write it down with me. 2 times x square y cube plus 2xy plus 2y to the power 5. I took 2 inside, and dy equal to 0. So this is my new equation. Agree, guys? This one is my new equation.
Can you hold it up a little bit, sir?
Yes, sure. Is it okay? I will take the picture and send to Nina. Okay. So again, this is my mxy first part, and second part is my nxy. Mxy and nxy. It is not required, as I told you, but if suppose somebody is curious to know this thing, so let's go for del m by del y. Find del m by del y, guys, by your own. You're going to get 4xy cube plus 2y. And del n by del x, you're going to get 4xy cube plus 2y. Am I right, guys? See, I'm getting the same thing. If you take again the partial derivatives with respect to m with respect to y and n with respect to x, now I'm getting the equality. I told you, once you find the proper integrating factor and multiply that your given equation by the new integrating factor, that integrating factor will make your equation always in the exact form. So therefore, now let me put double star over here, okay? My original equation is star, new equation is double star. So now the double star is an exact differential equation because the condition is satisfied. Del m by del y equal to del n by del x for the new condition. And therefore my general solution is given by integration y constant. But for double star, general solution for double star, please keep in mind this thing, new equation. So y constant xy to the power 4 plus y square n dx plus terms free from x or terms independent of x. First term involves x, second term involves x, third term is 2y to the power 5 dy does not involve x. And I'm getting like this, look at here. Agree? Agree?
Yes, sir.
Okay, thank you. So let's go for the first integration where y is constant. So I'm getting x square y to the power 4 by 2, y constant. So y square times x plus 2y to the power 6 by 6 equal to c. And this is my answer, or this is my solution. This is my solution. Agree?
Yes, sir.
Yes, sir.
Any doubt? Let me take the picture and send to Nina. This is the page number. What was the page number we were working with? Page number. Oh, I don't know why the page number is not mentioned here. Here 15 is there, but ours is 14 probably. I don't know. Forgot to give the number. Yeah. Oh, this is 14. And then 15 is there. Okay, so let me. Okay, I would say 14 plus. Page number 14 plus. Okay. After 14, you can go for this one. Let me take the picture right now and send to Nina before I forget. Okay, guys. Let's go for this example. Nina, you got it.
Just got it, sir.
Yeah. Okay, let's go for example. All these examples, they are from your question 11. Question 11. E to the power 2y y cosine xy dx plus 2x e to the power 2y x cosine xy plus 2y dy equal to 0. See, if I write over here simply x, life is really very easy. Example is easy. But here's a product x and y. Here's a product x and y. And that's why particularly I put bracket xy. See, xy. If the bracket is not there, even though you can consider this one as xy. Of course, brackets make some more sense. Are you getting me, Gage?
Yes, sir.
Are you tired?
A little bit, sir.
A little bit. Just 10 more minutes, okay? Okay. So, derivative is important over here for this example because of this product xy. I don't know how good you are at your Calc 1. I hope you guys are good, but let me find. Let me just test you. Or let me teach you. Let's look at here, guys. Del m by del y. First term is easy. E to the power 2y. Derivative of 2y is 2. Chain rule for the first term. Minus. Here is a product rule. Be careful, all of you. be careful, y times cosine xy product rule with respect to y. So my y as it is and derivative of cosine is negative sine. So this negative will be positive. So positive sine and xy should be in the bracket. And derivative of xy with respect to y is just x. So this x is there. Don't forget this thing, please. Chain rule. Plus, because we started product rules, I took y as it is. Now my cosine xy as it is. Cosine xy as it is. And derivative of negative y with respect to y is just -1. So -1. So that is the derivative, partial derivative of m with respect to y. All you guys agree with me or not? Any doubt? Will, are you okay? Alex?
Yep.
Nina?
Yes, sir.
All you guys good?
Yes, sir.
Yes, sir.
Good. Good. Now del n by del x. With respect to x means e to the power 2y is constant. 2 is constant. With respect to x is simply 1. So 2 e to the power 2y. 2 e to the power 2y. Minus bracket. With respect to x, x involves here, x involves here. So both the terms in product also we have to use the chain rule. So derivative, first time my x as it is. So let me keep my x as it is here. And derivative of cosine is negative sign. Negative will become positive. Agree? I'm sorry. Yes. So derivative of cosine is negative sign. Negative sign. I took this negative outside, so don't change this one. Derivative of cosine is negative sign, so negative of sine of xy. And chain rule, derivative of xy with respect to x is simply y. I wrote it down my y over here. Agree?
Yes, sir.
Yes, sir.
Ilyas?
Makes sense.
Good. People are making mistake over here whenever we have some product and chain rule simultaneously. And finally, it is with respect to x, simply y is there, so derivative is 0. If you open this bracket, 2 e to the power 2y minus cosine of xy and minus plus xy sine of xy. And if you can see over here, see, this term is same as this term, this term is same as this term, so they are same. They are same means del m by del y equal to del n by del x. Exact differential equation. You don't have to go for that integrating factor. Just go for the solution. E to the power 2y minus y cosine xy. Again, be careful, guys. Again, be careful. Terms free, y is constant and here terms free from x. So naturally, we are getting simply one term, 2y. Okay. So here, e to the power 2y, constant, pull it out, and integration of 1 is x minus y. Now, who is the right person? Who wants to take this one? What is the integration of cosine xy? Look at my cursor. I am looking for integration of cosine xy. No? Don't disappoint me, guys. Calculate.
Would it just be a sine xy?
Wrong. Wrong. Any other guy? Gauge?
Sir, is it sine xy over y?
Sine xy over y. Nina, is he right? He says,
I would multiply it times y. So y times sine xy divided by y.
Nina, I'm not asking you derivative, I'm asking you integration.
Oh, then I don't know.
Ilyas is absolutely right. See here. Look at here, guys. We are taking cosine of xy and we are looking for what? Integration. Where I forgot. Oh yeah. So y constant. So integration of cosine is sine. Xy, just angle xy. Your constant, suppose y is 2. So actually it is cosine of 2x, right? So integration is sine of 2x and divided by 2, because you can take 2x equal to your u sub. Your y is constant. If you use your u sub, you're going to divide by 2. In derivative, you are multiplying. Integration, you are dividing. So divide by 2. Here y is constant, divide by y. So Ilyas is absolutely right. Very nice. And 2y square, here 2y comes free from x with respect to y. So 2y square by 2, simply y square. And that will give you the answer. So sometimes don't think that only integrating factor will make your exam complicated. No. Sometimes you have to be very careful. Even see here, we are not finding an integrating factor, even though we have to be very careful about our derivative, because chain rule and product rules are working simultaneously. Examples of today's class and we'll stop. Okay, guys? Y to the power 4 plus y square and 2x square. I think we did the same example, right? Again, it's repetition.
Yeah,
No,
I think we, yeah.
repetition, right? Yeah. So, yeah, they are same. So it's a repetition. Let's go for this one, number 5. 6xy. I think I solved all 5 examples of exact differential equation. You guys will feel happy. All examples are solved over here from your practice test. 6xy dx plus, this is dx. 4y plus 9x square dy equal to 0, y at 1 equal to 2. Right? Y at 1 equal to 2. This is m, this is n. Which one is the smaller function? M. Right? So first let me find partial derivative. 6x, 18x. So they are not same. Equation is not exact. We need to find the integrating factor. I need to use the formula where m is a division. M is a division. So del n by del x by del m by del y. So this minus this. 18 minus 6 is 12. And n is 6xy. Divide by 6xy. So you are going to get 2 over y. Use this one. This is just a function of y. So your integrating factor is e to the power 2y dy. Some people are finding this thing and whatever they are getting over here, they use this one as the integrating factor, but that is wrong. This is just a function of y. Integrating factor, you need to find after this line. So e to the power 2 over y dy, e to the power 2, and 1 over y is ln of y. So this is ln y, integration. Use ln property, take this one as an exponent. So e to the power ln y square and gy. Multiply your given equation by star, given equation star by this integrating factor. So it is xy cube multiplied throughout by y square. So this is a new equation. New equation will always, as I told you, in the exact form. You don't have to check it. If you want to check, that's fine. And general solution, that is 6xy cube, first term with his y constant. Second term, free from x. X is here, remove it. So just 4y cube and dy. Here integration y constant, so 6x square by 2y cube and 4y to the power 4 by 4, and you are done. And you are done. Agree, guys? You know, I gave you one example in homework. I solved one exact differential equation. I told you that the same example can be solved using homogeneous power 4, power 4, power 4. Am I right?
Yes, sir. Yes, sir.
Yeah, this is the solution. I didn't want to tell you, but okay. Let me let you know. I solved these examples. See, look at the solution. It's a long solution, but that's not a question whether the solution is long or short. Question is it possible to solve that by different way? Yes. See, I just took dy by dx. Powers are same, 4, 4, 4, 4, 4, 4. So homogeneous method, y equal to vx. All the y's are replaced by vx. And left hand side, this derivative, this one, I took the common out, cancelled it. I sent this v to other side because now I have just v on my right side. So v to other side, every v's are on right side and x are on left side. I took the LCM. I cancelled the common things. Finally, I'm getting the expression like this. X dv by dx equal to this one. I send this x to this whole function to other side and x dx other side. So I'm getting like this. This is other side. So this is a numerator, this is a denominator here. And dv, negative 1x, 1 over x and dx here. But look at here. This is really good. 5v to the power 5. 5v cube minus 5v square minus 5. What is the derivative of this function? 25, or I can take 5 out. Suppose I take 5 out. The derivative of v to the power 5 is 5v to the power 4. Agree?
Yes, sir.
After taking this 5 out, 5, 5, 5, 5 common, derivative of v to the power 5 is 5v to the power 4. Derivative of v cube is 3v square. Look at here, I'm getting first term. I'm getting second term. Derivative of v square is simply 2v, negative sign is there. And constant 0. So derivative of denominator is there in numerator. So this is my u, so this is my du. Right? If this is my u, this is my du. Look at here. So it looks like a very big function, but integration is quite simple. Du by u and negative 1 over x dx and this one. Right, guys? So 1 over u integration is ln u. Agree?
Yes, sir.
Yes, sir.
Ln x. I told you yesterday, when all your other integrations are in terms of ln, blindly take your constant also ln c. ln c and ln c. See? And I simplified this one and I got the answer. Right, guys? So this is the differential equation. Last part, I think I did everything. So that is the end of exact differential. A few more examples. One example was left out. Just for your practice, just go through all these examples, guys. You have everything on your hand. One non-linear example, which I have not solved. Of course, this is from a practice test, but I did not solve that one when I was teaching you yesterday. The non-linear example too. Okay. Just go through this one, non-linear example. Already we went through the method. I solved number of examples over here so that now no one will be having these questions that you don't have the answers. Almost 90% of the examples are solved from the practice test. 90%, probably more than that. And the rest of the 10%, they are just similar. So you won't be having any problem. Okay, guys. And the last portion, very last portion, you want me to stop over here? If you want me, if you can give me 5 more minutes, I can finish this. Actually, that's not a big deal. Just sometimes you have equation like this, 1 minus x minus y, like this. Just take x plus y equal to u. That is called substitution. Substitution method. So it is u by dx minus 1, 1 minus u by u. Send this one to other side, LCM. So it is just separable variable. So sometimes some u sub will convert your example to separable variable. And you can get the answer directly. Same here. X plus y plus 1 square, that is your u. Derivative is this one, 1 plus dy by dx. Plug it over here. And separable variable, again answer. Right? I consider some of the examples which I have not covered in on your first page of the practice test assignment. I got it down over here as a review. That means now you will be having almost 100% of the practice test solution. Are you happy now?
Sir.
Yes, sir.
Very happy.
Somebody
Sir.
just asked me the answer key. Just answer keys. I am providing you complete solution. Happy? Don't you think now the ball is in your court? If I solve everything for you and ask, and I promise you to ask from the same thing.
Yes.
This verification I did not solve, but it is over here, question 2A. So whatever I have not solved, I covered over here as a part of the review. Look at over here. Will asked me in the beginning of this class, Will asked me this question. And Nina gave me this example, right? And we solved it. And Alex, you had some problem in this example.
Yep.
Okay. This is the solution. Everything is done over here. Happy? Only thing is, I think I have not used over here y0 equal to 0 because that's simple. You can work by your own. I have not solved. I just wrote it down answer, but that's not the answer. You need to use the initial condition. And one more problem. Ooh. Right. I solved the same example, that product xy, or probably different, I don't know. Just verify. That is the end, guys. I gave you everything. Now the ball is in your court. Work hard. Go through each and everything. I want to give you really good grades. Yeah, I will try my best to be liberal within my limit so that you can secure good grades in the first exam. Because once, you know, there's a psychology. If you are getting good grades in the first exam, that means you will get some more, you will be getting confident. And it will give you some more moral work, moral support to work hard for the second test. Right?
Yes, sir.
Okay, guys. Stay safe. Thank you so much for you too. Thank you so much for 5-10 more minutes. I really appreciate. Take care of yourself.
Thanks, sir.
Yeah.
Have a good day, sir.
Bye.
Have a good weekend, sir.
You too, guys. Bye. Thank you.